In this video, I'm focusing on differentiation. So finding the gradient by drawing a tangent is not very accurate, but we can find it algebraically. Differentiation is the process of finding the gradient function, or the equation for the gradient, the equation that's going to allow you to find the numerical gradient at each point on the curve, because the gradient of the curve changes depending on where you are on the curve. So this is the rule. So let's just get to grips with the words. The number multiplied by x is called the coefficient. Of course, this is the power, and the constant is a number on its own without a variable, without a letter. To differentiate something like this, what you do is you multiply n by a, the power by the coefficient, to get a n. So I'm going to write this down. Multiply the coefficient by the power of x. And then you subtract the power, you subtract 1 from the power. This is the differentiation rule. Now, a question might ask you to differentiate in different ways. It might say differentiate. It might say find dy over dx. It might say find the gradient function, the equation of the gradient. It might say find an expression for the gradient. It means the same thing. It wants you to differentiate. So the first section says differentiate. So dy over dx, 2 times 3 is 6, x, and then 3 minus 1 is 2. Dy over dx, 5 times 4 is 20. 5 minus 1 becomes x to the power of 4. Dy over dx, negative 2 times 7 is negative 14. And then note, when I take away 1 from negative 2, I have x to the power of negative 3. Negative 1 times negative 6 is a positive 6, x. And then again, when I take away 1 from negative 1, it becomes a negative 2. This is actually an equation of a straight line, or an expression of a linear graph. So dy over dx is just 2. The gradient is 2. I know what the gradient is, and it's never changing. But if you have a closer look, this is x to the power of 1. 1 times 2 is 2. 1 minus 1 is x to the power of 0. And of course, anything to the power of 0 is 1. 2 times 1 is 2. You wouldn't be given something like that, but I thought we would go through it just to remind ourselves. Okay, a half times 10 is 5. X. A half minus 1 is negative a half. Again, this is an expression for a straight line, a linear quantity. So 1 times 1 is 1, x to the power of 0, which is 1, that's 1. And this, of course, there's an invisible 1. 2 times 1 is 2. And then x minus 1, 2x. We don't need to put to the power of 1. And then this set of questions says find dy over dx, and some of them are given as equations with y equals. You are still only differentiating this part. You're not differentiating the y. You're differentiating the whole equation y, but in terms of x. So you're never gonna try and differentiate y. Okay, so dy over dx equals 8 times 7 is 56. and then 7 minus 1, x to the power of 6. What do you do with the constant? You do nothing. You don't differentiate unless there is a letter. The constant doesn't actually affect the gradient. The constant is telling you where the y-intercept is. It has nothing to do with the steepness or the slope of the curve. And for number 2, dy over dx, 4 times 2 is 8, x cubed. Again, we don't do anything with that. For number 3, dy over dx, that's a 1, 2x, nothing to do with the constant. Negative 1 times 2, negative 2x. Take away 1, negative 2. Nothing to do with the constant. This is a 1. dy over dx equals 2x. Nothing to do with the constant. This is an equation of a straight line graph. We don't need to differentiate to know what the gradient is, and it's not a function, it's not an equation. The gradient is 1. And again, that does not affect the gradient, that's the y-intercept. And y equals 8, if I draw that straight line, that's x, that's y equals 8. It's a line that cuts y-axis at 8. It's a completely horizontal line. The gradient is 0. So these are just things you need to be aware of. Let me put that. Okay. And again, find the gradient function, differentiate. And to differentiate, you would differentiate each term separately. So I would differentiate each term separately, and remember that the sign goes before each term. So the negative belongs to the x squared. dy over dx. 3 times 5 is 15, x, 3 minus 1 is 2. 2x, well, that's very easy. This is x to the power of 1, 1 minus 1 is 0, x to the power of 0 is 1, so it simply becomes plus 2. There is, of course, an invisible one here. 2 times negative 1 is negative 2x, x to the power of 1. Again, we don't differentiate the y, we're differentiating y in terms of x. 6 times 4 is 24, x cubed. 2 times negative 2 is negative 4x, and minus 7 is the y-intercept. Okay. Negative 1 times 2 is negative 2, and minus 1 becomes a negative 2. The 3 is an intercept, we don't differentiate it. Plus 4, the x disappears. And then we've got negative 2 times negative 6 is plus 12x, and minus 1 becomes minus 3. So negative 2 take away 1 is negative 3. And again, this is a 1x to the power of negative 1. So dy over dx is negative 1x minus 2, because I'm subtracting 1 from the negative 1. Okay, minus 3, the x disappears when I differentiate, minus 3. The negative 4 is a y-intercept, I don't differentiate it. Negative 2 times negative 5 is a positive 10x to the power of negative 3, because I'm subtracting 1. And I've differentiated. Now, the final few, I've said find dy over dx, but the first thing you need to do is to simplify. So the first thing you need to do before differentiating is to simplify first. So add what needs adding, multiply what needs multiplying. And we'll see the rest of the examples. So x squared times 4x cubed, of course that's a 1, 1 times 4 is 4. X squared times x cubed is x to the power of 5. So that's what I do first, before differentiating. And then I differentiate dy over dx. 5 times 4 is 20, x to the power of 4. So simplify first. That is interesting. If you have a square root, a surd of some sort, you need to, step 1, turn the root or the expression into index form. The square root is the power of x. Okay, so that's laws of indices. Square root is the power of x. So this means 4x all to the power of a half. What it's not is 4x to the power of half. It's not just the x that's the power of a half, it's all of it. 4x is to the power of a half. So if I put that all in red, 4. And what you need to do is apply that power to both parts. So it's the square root of 4, it's 4 to the power of a half, times x to the power of a half, which is 2x to the power of a half. Now you can differentiate dy over dx. So that's step 2. Half times 2 is 1. X, and then half minus 1 is minus a half. Of course, you don't need to write that. That's optional. This is a division. So 10 divided by 5 is 2. X to the power of 6 divided by x squared is x to the power of 4, because we subtract the powers. So I do the division first. And then step 2 is my differentiation. 4 times 2 is 8, x cubed. This is also a division. This is x to the power of 1. And when I am dividing, I subtract the powers. 1 take away 5 is negative 4. So that's my step 1. And my step 2 is to differentiate. Of course, this is an invisible 1. Negative 4 times 1 is negative 4. X to the power of negative 5, because I'm subtracting 1 from negative 4. And this is also a division. And you don't put anything as decimals, you leave everything as fractions, okay? So leave all as fractions. So if it's not a whole number, you leave it as a fraction. 8 divided by 3 is 8 over 3. And then x to the power of 7 divided by x is x to the power of 6. And then you would multiply 8 over 3 by 6, and you would get, you would times. So 6 times 8 over 3 is 16. So when we're differentiating, 6 times 8 over 3 is 16, and then x to the power of 5, because I take away 1 from the 6. And again, everything is inside the square root. So this is 36x cubed all to the power of a half, which means that you have to apply the power to both parts. 36 is to the power of a half, and x cubed is to the power of a half. The square root of 36, or 36 to the power of a half, is 6. And then those two powers are multiplied together, and you get x to the power of 3 over 2. So that's your step 1. You simplify. And then step 2 is you differentiate. You find dy over dx. 3 over 2 times 6. So 1.5 times 6 is 9. And 3 over 2 minus 1, 1.5 minus 1 is a half. This is a multiplication. And when we multiply, laws of indices, we add the powers. So x squared times x is x cubed, minus 1 times negative 3, x squared times x to the power of negative 3. Again, when we multiply, we add the powers. So 2 plus negative 3, negative 1. So it becomes x to the power of negative 1. That's your step 1. And then step 2 is we differentiate. 3 times 1 is 3, x squared. Negative times negative is a positive 3, x to the power of negative 2. And I think, yeah, that's the end of this video, just focusing on differentiation.